In this video, we'll take a look at section 6.1, which is on radical expressions. Now, our first objective is we're going to take a look at square roots and square root functions. Now, principal square root, what this means is non-negative. Okay, so we're going to take a look at the non-negative solutions for square roots. Now, square root of a, this is equal to c if c squared is equal to a. Now just take a look at some terminology here. Now the symbol, this is called the radical sign. Now the expression inside of the radical sign, this has a special name. This is called the radicand. Let's take a look at an example. Simplify square root of 16. So what we're trying to do is we're trying to find a number where if we raise it to the second power, it will give us 16. Okay. So for this example, square root of 16, this is equal to 4. And this is because 4 raised to the second power gives us 16. Now, principal square root, we're taking a look at the non-negative solution. So what that means, so negative 4 raised to the second power, this also gives us 16. Okay. But the principal square root means non-negative, so we just take the positive solution. So square root of 16, this is just equal to positive 4. Okay. Let's take a look at the next one. So square root of 49. Try and find a number raised to the second power. That gives us 49. Which will, in this case, would be 7. So this is because 7 raised to the second, this equals 49. Next one, we have negative and then square root of 49. Okay. So now think about square roots as, say, like parentheses or brackets. It's like a grouping symbol. So you have to actually do that operation first. So this minus sign, this is going to stay on the outside. And now square root of 49, like we saw in the previous problem, this gives us 7. So our final solution here is negative 7. So always perform the square root first, and then do whatever's on the outside of it. Now, next problem, we have square root of negative 16. So remember, what we're trying to do is we're trying to find a number raised to the second power that will give us, now in this case, negative 16. So a lot of mistakes I see is students will put negative 4. But remember, negative 4 raised to the second power, this equals positive 16, not negative 16. As a matter of fact, whenever you raise any number to the second power, doesn't matter whether it's positive or if it's negative, it's always going to end up being positive. Okay. So in this particular case, square root of negative 16, this is not a real number. And we'll take a look at what this would be later on. But for now, this is not a real number. So whenever you have the square root of a negative number, this is not a real number. Because there is no number where you raise it to the second power, it'll give you a negative result. Next example, now we have the square root of a fraction. So first, the minus sign is going to stay on the outside. And now square root of 25 over 64. We're trying to figure out what number can we raise to the second power to give us 25 over 64. Now when you're dealing with a fraction, there's a trick that you can use. Take the square root of the top and take the square root of the bottom. I shouldn't say trick, it's really just a property. So now we have negative, now square root of 25, that gives us 5. Square root of 64, that gives us 8. So we have negative 5 over 8. Now notice that the minus sign is on the outside of the square root. That's fine. Okay, it just stays on the outside. But if you have a negative on the inside, this is when you have not a real number. Next example, okay, square root of 17. So square root of 17. So we have to try to find a number where if we raise it to the second power, it will give us 17. Well, in this particular case, there isn't a whole number where if I raise it to the second power, it will give me 17. There's no whole number that would work. Okay, so in this particular case, I just have to use a calculator to figure out what the result is. And I'm going to approximate what the solution would be. However, I do know what numbers it's going to be between. Okay? So square root of 16, this is equal to 4. The next perfect square would be square root of 25, which is equal to 5. So square root of 17 has to be a number between 4 and 5. Since it's a little bit closer, since it's a lot closer to 16, okay, this would be about 4 point something. Let me put in the calculator. So this would be approximately 4 point, I'm going to round to 3 decimal places. This would be 4.123. Yeah, so some of the square roots, you just have to approximate it by using a calculator. Now, let's take a look at finding the domain of a square root function. So, domain of a square root function, what you're going to do is take the radicand and set it greater than or equal to 0 and then solve. So inside of your square root, this has to be non-negative, meaning it has to be greater than or equal to 0. You can't have a negative number inside the square root. So what we do is we go ahead, take the radicand, which is x minus 5, and you set this greater than or equal to 0. And then this will give us our domain. Well, let's go ahead, solve for x. So add 5 to both sides. We get x is greater than or equal to 5. Now, just recall, domain is all the values of x that it can take on without making the function undefined. Okay. Well, the only thing that will make this square root function undefined or give you a result that's not a real number is if it's negative inside of the square root. So we go ahead, take the radicand, and set that greater than or equal to 0, and then we solve. So we have x is greater than or equal to 5. Now, writing this in interval notation, this will go from 5 to infinity. Notice that 5 has a bracket next to it. This is because it could include 5. Next problem. Find the domain of the function. Now we have g of x is equal to square root of 2x plus 3. So we want to make sure that our radicand is non-negative. So take the radicand, which is 2x plus 3, set this greater than or equal to 0. Now solve for x. Let's go ahead and subtract 3 from both sides. We get 2x is greater than or equal to negative 3. Next step, divide by 2. We get x has to be greater than or equal to negative 3 halves. Interval notation, we'll have a bracket going from negative 3 halves all the way to infinity. Take a look at a different type of problem. Now for this next example, we have evaluate f of x equal to negative square root of x for each of the following. So we're just evaluating a function here. So f of 4, all I have to do in this case is plug in 4 in for my x. Now simplify, so that minus sign stays on the outside. Now square root of 4 gives me 2. So f of 4, this is equal to negative 2. Let's try the next problem out. So f of 7, now we're plugging in 7 for our x. So it's going to be equal to negative, and we have square root of 7. So now, square root of 7, there isn't a whole number that I could raise to the second power that gives me 7. So I'm just going to leave my answer the way it is, negative and then square root of 7. This is our exact answer. So if you leave it in this form, this is your exact answer. But if you use a calculator, what you're getting now is an approximation, because now this decimal, this just keeps going on forever and ever. So let's go ahead and use our calculator, figure out what the square root of 7 is. So this will give us negative, and then we have 2.646. So I just rounded to 3 decimal places. Now in the homework, be careful with what it's asking for. If it says to approximate your answer, to like say 3 decimal places, then it's asking for the decimal form. If it asks for the exact answer, then you just leave it as the radical. Just leave it as negative and then square root of 7. This is the exact answer. We have one more. Now f of negative 3. So f of negative 3, this is equal to negative, and then we have square root of negative 3. Now be careful in this situation. So square root is not the same as like parentheses, where if you have negative and then parentheses negative 3, this becomes positive 3. It doesn't work like that with square roots. So since square root's an actual operation, you have to do the square root part first. But now notice, we have a negative inside the square root. So right away, I know that this is not a real number. So later on, we'll see how to simplify that even further. But for now, not a real number. This is something called an imaginary number or a complex number. We'll see that later on, I believe in chapter 8. Now let's take a look at graphing. So we have g of x is equal to negative and then square root of x. So with graphing, all we've really seen so far is linear functions, where we could use the slope and the y-intercept. But when you get a function that's not linear, we can't really use the slope and y-intercept. The reason why is because the slope at each point is going to be different. So in this particular case, what we're going to do is just go ahead and create a table. So let's create our xy table and plot some points. Now, one of the very first points that you want to choose is whatever makes the inside of that square root 0. Well, if I plug in 0 for my x, that will make inside the square root 0. Let's go ahead and choose that value. So now we have to figure out what y is equal to. Remember, g of x, this is just the same thing as y. So this is really just y equal to negative and then square root of x. So I have y is equal to negative and then square root of 0. This gives me negative, and then square root of 0 is 0. Negative 0 is just 0. So that gives me 1 point. Now be careful here. You can't choose any values for x that's going to make inside of that negative, inside the square root negative, because that's not a real number. It's not part of the domain. Remember the domain here, you would have to set the radicand greater than or equal to 0. So we have to choose values for x that are greater than or equal to 0. Okay, so we can't choose any negative x values in this case. Let me actually leave that up. Okay. So next value you want to choose is whatever is going to give you a perfect square. So make your life easier. Choose values that's going to give you a perfect square. Something that's going to give you a whole number. Well, I know square root of 1 is a whole number. Square root of 1 is just equal to 1. So I can plug in 1 for my x. So this gives me y is equal to negative and then square root of 1, which is negative and then 1. So square root of 1 is 1. So if I plugged in if I plugged in 1, my y value would be negative 1. Let's find a couple more points. Next perfect square would be 4. So I'd have y is equal to negative and then square root of 4. So remember the minus stays on the outside. Now square root of 4 gives me 2. So I have 4 negative 2. Next perfect square would be 9. So let's plug in 9 for x. We have y is equal to negative and then square root of 9. So the minus stays on the outside. Square root of 9 gives me 3. I'm sorry, negative 3. My final result is negative 3. So now let's go ahead and plot these points. So I have 0, 0. I have 1, negative 1. I have 4, negative 2. Then I have 9, negative 3. So let's go ahead, graph it. And I get my graph. Now be careful, my graph isn't going to go past x equal to 0, because all these values for x, they're not in the domain. It'll give you an imaginary result. It'll give you not a real number. Let's take a look at another one. So this one a little bit harder. So graph f of x equal to 2 times the square root of x plus 3. I'm just going to go ahead and change my f of x to y. So I have y is equal to 2 times the square root of x plus 3. Now let's go ahead and create a table. Okay, now very first value you want to choose in this case. First, let's go ahead and find out what our domain is. So our domain, remember, you're going to set your radicand greater than or equal to 0. So you have x plus 3 is greater than or equal to 0. If I solve for x, subtract 3, I have x has to be greater than or equal to negative 3. Okay. Now, very first value you want to choose for x is whatever is going to make the radicand 0. So you want to determine what's going to make this part 0. What value for x? So I have x plus 3. So if I choose negative 3 for my x, that would work out. So now I have y is equal to 2 times the square root of negative 3 plus 3, which gives me 2 times the square root of 0, which gives me 2 times 0, which gives me 0. Okay, so my y value would be 0 in that case. Next, you want another perfect square. So the next perfect square would be square root of 1. So you have to determine what can I plug in for my x in order for me to get a 1 inside this radical. Well, negative 2 would work. So if I plug in negative 2, I have y is equal to 2 times, then I have negative 2 plus 3, which gives me 2 times the square root of, so negative 2 plus 3, this gives me 1. So I have 2 times 1, which gives me 2. Okay, so that gives me another point. Let's go ahead and find 2 more. Next perfect square is square root of 4. So you have to figure out what can you choose for your x to make the inside 4. Well, I know 1 would work. So I have y is equal to 2 times the square root of 1 plus 3, which gives me 2 times the square root of 4, which is equal to 2 times 2, which gives me 4. Now I have another point. So now next perfect square is 9, square root of 9. So in order for me to get a square root of 9, I need to plug in 6 for my 6 for my x. So I have y is equal to 2 times square root of 6 plus 3, which gives me 2 times the square root of 9. So I have 2 times 3, which gives me 6. And notice I get some nice whole numbers here. Now let's go ahead and plot these points and we could graph. So I have negative 3, 0, which is a point right here. I have negative 2, positive 2. I have 1, 4. And then I have 6, 6. And we get our graph. Notice my graph doesn't go past this point because all those values of x would make it a negative inside the square root, which would be undefined. It would be not a real number. Okay, so now this takes us to our next objective, which is the principal square root of a squared. So this has to do with variables. So if you have the square root of a raised to the second power, this is equal to the absolute value of a. Now the reason for the absolute value is to ensure that our result is positive. Okay. So let's take a look at some examples here. Simplify, we have the square root of y squared. Well, this follows the same form as that property that we just saw. So square root of y squared, this is equal to absolute value of y. So when we're dealing with variables, we just have to ensure that it is positive, or I should say non-negative. So that's the reason for our absolute value. Let's take a look at the next one. So square root of negative 24 raised to the second power. So using our property, this is equal to the absolute value of 24. Absolute value of absolute value of negative 24. Absolute value of negative 24 is just equal to positive 24. Next problem, square root of x plus 7 squared. So since we have a variable within this square root, so this again follows that same property. Pretend like our x plus 7 was just a. So this will be absolute value of x plus 7. Once again, the absolute value is to ensure our result is non-negative. Next problem, a little bit harder because it's not written in that form where it's some binomial squared. But if we take a look at that trinomial inside of our square root, we could actually factor that out. So if we begin factoring it out, this would be x minus 3 times x minus 3. So two numbers that multiply to give you positive 9 and add up to negative 6 is negative 3 and negative 3. But now we could rewrite this as the square root of x minus 3 squared, where now it has that same form as the property. So this becomes absolute value of x minus 3. So remember, these absolute values, these are necessary when you're dealing with variables. Now that leads us to our last objective, which is cube roots. This property, so cubed root of a, this is equal to c, if c cubed is equal to a. Okay, let's take a look at an example. Simplify, we have the cubed root of 64. So when we were dealing with square roots, we're trying to find a number that if we raise it to the second power, it'll give us what the radicand is. Now with cubed roots, we're trying to find a number where if we raise it to the third power, it'll give us what the radicand is. So since we have cubed root of 64, we're trying to figure out what number raised to the third power will give us 64. For 64, this would be 4. And this is because 4 raised to the third power, this is equal to 64. Okay, what about this next problem? Cubed root of negative 64. So when we were dealing with square roots, we couldn't have a negative inside of the square root. When you're dealing with cubed roots, it's fine to have a negative. Okay, and this is the reason why. So cubed root of negative 64, this would be equal to negative 4. And this is because negative 4 raised to the third power, this actually gives me negative 64. It wouldn't work for square roots. So say you had square root of negative 64. This is not equal to negative 8. Because negative 8 raised to the second power, this gives us positive 64. So like what I mentioned earlier, you can't raise a number to the second power and it gives you a negative result. It's always going to end up being positive. But with cubed roots, you can. So negative 4 times negative 4, that gives us positive 16. And then times another negative 4 gives us that negative 64. Next problem, simplify. So you have cubed root of 27y cubed. So this time we have a coefficient and we have a variable. We'll just work them out separately. Well, cubed root of 27, a number raised to the third power that gives us 27 is 3. And now we're dealing with the y. Well, y raised to the third power gives me y to the third power. So my answer here, in this case, is 3y. Now, even though we have a variable, since it's not a square root, it's a cubed root, I don't need the absolute value there. This is just equal to 3y. This is because 3y raised to the third power, this actually gives me 27y cubed. Last problem. So now we have cubed root of 8 times x plus 2 cubed. So first, let's take a look at cubed root of 8. What number raised to the third power gives us 8? In this case, it would be 2. And now the cubed root of x plus 2 to the third, this would give me x plus 2. Once again, this is because put this in brackets. So 2 times x plus 2 raised to the third power. This gives me 8 times x plus 2 raised to the third. So essentially what happens with these binomials is the cubed root and the third power, those cancel out with each other. Alright, so that was it for section 6.1. Remember, if you have any questions, just email me and I'll help you out.